This week we'll be covering Chapter 3, 3 Claims, 4 Validities, Interrogation Tools for Consumer Research. This week's topic builds on some of the material we talked about last week. If you remember, we talked about how to go about finding research and to be critical consumers of that research. This week we'll go into more detail on the ways to break down the validity of different information. You can see here the 4 main topics we'll cover in this chapter. First, we'll talk about variables, what they are, how they're defined, measured, and manipulated. Next, we'll cover the 3 claims that can be made about different variables. These are frequency, association, and causal claims. We'll then cover the 4 big validities, or ways that we use to measure the soundness or integrity of a claim. These are construct, external, statistical, and internal validity. Finally, we'll cover how these validities are prioritized differently depending on what type of claim is being made. So let's start off by talking about variables. A variable, just like it sounds, is something that changes or varies. Because of this, it needs to have what are known as levels. A variable must have at least 2 levels, but it may have more. For example, take this made-up statistic. 60% of college students own a vehicle. In this example, the variable is vehicle ownership. That variable has 2 levels, owning a vehicle and not owning a vehicle. Here's another made-up example. People who attend church regularly lie more often than others. In this example, we actually have 2 variables that are being compared. One variable is church attendance, which may have 2 levels, say someone who attends church at least once a month versus someone who does not attend church at least once a month. While the other variable is the amount that somebody lies, possibly measured using some numerical score on a lying inventory exam. A variable is different from what's called a constant. A constant does not vary, it stays the same, or remains constant. In the previous example, that 60% of college students own a vehicle, college students is a constant, as it doesn't change across the different levels of the variable. Next, let's talk about some different types of variables. I'll talk about the difference between a measured variable and a manipulated variable, as well as the relationship between a conceptual variable and an operational definition of a variable. Let's start off by looking at the difference between measured and manipulated variables. In a study, researchers either measure or manipulate variables. Measured variables are observed and recorded by the researcher. Examples of a measured variable include height, IQ, gender, or hair color. However, psychologists also measure more abstract variables, such as depression or stress. On the other hand, manipulated variables are controlled by the researcher, usually by assigning participants to different levels of that variable. As an example of a manipulated variable, a researcher might assign some people to take a test in a room with many other people, and assign others to take that test alone. Here the variable might be isolation during test taking, and the researcher is controlling that variable for each participant. Some variables can only be measured but not manipulated. For example, you cannot assign participants to be a particular age, as age is a naturally occurring variable. Also, sometimes it is unethical to manipulate certain variables. For example, in a study on the long-term effects of education, you couldn't ethically assign some children to high-quality school and others to low-quality school conditions. Some variables can be either manipulated or measured. For example, if childhood extracurricular activities were the variable of interest, you may measure whether children already take music or drama lessons, or you could manipulate this variable by assigning some children to take music lessons and others to take drama lessons. Often a challenge we face in psychology is the idea of what are known as conceptual variables, constructs, or conceptual definitions. These are variables that are abstract, or up in the clouds, so to say. They're variables that are hard to specifically define and measure. For example, variables such as anxiety, depression, or fear are often difficult to quantify or measure. How would you measure one person's anxiety or fear to be more or less than another person's? In order to do that, we need a way to understand the variable in a way that we can operate or use it with. This is what's known as an operational definition, operational variable, or to operationalize something. This is the process researchers use to turn a conceptual definition into a measured or manipulated variable. Look at the table on screen. You can see how one might go from a conceptual variable, such as car ownership or expressing gratitude, to an operational variable that has measurable, comparable levels. It's also important to understand that there isn't necessarily one specific way to operationalize a variable. In this example, we have the conceptual variable of school achievement. Here we can conceptualize this in 3 different ways. We could measure school achievement through a self-reported questionnaire given to the student, or we could simply check their actual records. Or maybe we use their teacher's observation of their progress as a measurement of achievement. The point here is that just because someone measures a conceptual variable one way, doesn't mean there isn't another way to conceptualize it. Now that we've talked a bit about what variables are and how to conceptualize them, let's take a look at what type of claims we can make about such variables. When I say claim, what I mean is essentially an argument that someone is trying to make. In psychological research, there are 3 different types of claims someone can make. The first are frequency claims, or an observation on how often a variable occurs. The second are association claims, or an argument on how 2 variables are related with one another. The third is a causal claim. These are often the most difficult to make and describe when one variable causes another variable. You can see some examples of each type of claim on the right side of the screen. It's important to note that not all claims are based on research, and just because you read a claim about one or more variables doesn't mean you should take it at face value. Remember, we should always be thinking critically about the information we're given. Let's talk in more detail about each type of claim. Once again, frequency claims describe the frequency or rate at which a single variable is present. These always involve only one measured variable at a time. Some examples of frequency claims are statements such as, 2 out of 5 Americans say they worry every day. Just 15% of Americans smoke. 72% of the world smiled yesterday. Or 4 in 10 teens admit to texting while driving. Association claims involve describing how 2 variables relate to one another. Specifically, they argue that one level of a particular variable is associated with a specific level of another variable. Because these claims involve the relationship between 2 variables, they must always involve at least 2 measured variables. An example of an associated claim is people with higher incomes spend less time socializing. Here, the variables of income and time socializing are being related to one another, each at specific levels. Notice how this is a different claim than if I said people with higher incomes spend more time socializing. Here, the same 2 variables are being related, but time spent socializing here is at a different level. It's important to remember that the level of each variable is important. Some other examples of association claims include romantic partners who express gratitude are 3 times more likely to stay together, that people who multitask the most are the worst at it, or a late dinner is not linked to childhood obesity, study shows. When 2 variables are associated with one another, they are said to correlate. To correlate, or covary, means that as one variable changes, the other tends to change as well. It's important to note, however, that one variable is not causing the other one to change. We are simply observing that as one changes, so does the other. There are 3 basic types of associations: positive association, negative association, and 0 or no association. Positive associations, also known as a positive correlation, are when high scores on one variable are associated with high scores on another variable, or when low scores on one variable are associated with low scores on another variable. Think of this as 2 variables changing in the same direction together. In this example, we can see the relationship between romantic partners' expression of gratitude related to their relationship longevity. Here we see a positive relationship because when higher amounts of gratitude are expressed, relationship longevity is also higher. You can see this by the way the scores trend on the graph. If we were to draw an average line or slope on this chart, we would see that it goes up as we move from left to right. Here we see an example of a negative association, and just by looking at the graph, you should start to see a difference from the previous relationship. A negative association, or negative correlation, are when high scores on one variable are associated with low scores on another variable. or when low scores on one variable are associated with high scores on another variable. Think of this as two variables changing in opposite directions as one another. This example shows the relationship between someone's frequency of multitasking and their skill at it. We can see that as people's frequency increases, their skill decreases. Again, if we were to draw a slope line, we can see that it goes down as we move from left to right. Finally, we have zero or no association. This is when there is no association between the two variables. There is no pattern in one variable changing as the other changes. An example here is the claim that a late dinner is not linked to childhood obesity. We can see that there is no relationship between the time one eats dinner and their childhood weight. Again, if we were to draw a slope line in this example, we would see that it does not change as we move from left to right. Some association claims are useful because they help us make predictions. Making a prediction based off of an association claim helps to make our estimates more accurate. But we can never fully know what will happen in the future. I said before that association claims do not show that one variable causes the other to change, only that we observe them both changing together. This is why we can estimate what might happen to one variable when another variable changes, based on the past relationship between them. But we cannot say for certain what will happen because one variable may not be directly causing the other to change. The stronger the association between the two variables is, the more accurate we can make our predictions, and vice versa. The weaker the relationship, the less accurate our predictions will be. Both positive and negative relationships help us to make such predictions. However, zero associations cannot be used to make predictions, as they do not give us any meaningful information about the variable's relationship. Fear not though, because if you remember, there's a third type of claim I mentioned earlier: causal claims. These are what we use to determine if one variable directly causes another. One way to distinguish between an association claim and a causal claim when reading research or results is to look for the specific language that is used. Terms like associated with, linked to, or is tied to are association claim verbs, whereas terms like causes, effects, or changes are causal claim verbs. We're not going to go too far into causal claims in this chapter. Just know that they are the third type of claim that can be made about variables. They rely on manipulated variables in order to control the change of one variable and observe the effect that has on another variable. As we discussed last week in Chapter 2, there are other ways of knowing besides research. For example, experience, intuition, or authority. Not all claims that we see, hear, or read about in the popular media are based on research. Some examples of claims based on something other than research include headlines that might read as 12-year-old's insight on autism and vaccines goes viral. Living in the shadow of Huntington's disease. Baby born without skull in the back of his head defies odds. Next, we're going to look at how we can go about interrogating each type of claim and uncover the integrity of that claim using the 4 big validities. Remember that validity, or valid, means reasonable, accurate, or justifiable. Validity is the appropriateness of a conclusion or decision. So what are the 4 big validities I keep talking about? They are construct validity, external validity, statistical validity, and internal validity. Construct validity is how well the variables in a study are actually measured or manipulated. Remember how conceptual variables are turned into operational variables so that we can measure them? Well, construct validity is a measure of how well this was done. Did you do a good job turning your abstract variable into a measurable variable? If you did, then you'll have good construct validity. You are valid in your construct. External validity is the extent to which the results of a study generalize to some larger population. For example, if you conduct a study on US school children, and for your sample you use Mrs. Jones's 3rd grade class as your participants, how well will your results apply to all US school children is measured by your study's external validity. Statistical validity is the extent to which the data supports the conclusions. It's important to ask to what extent and how strong the statistical relationship between the variables in a study is. The statistical significance of a study determines the probability that the results either occurred by chance or are a true depiction of your claims. Finally, there's internal validity. Internal validity is the extent to which variable A actually causes changes in another variable B, rather than some other variable C. For example, it's been shown that the rate of shark attacks increases as ice cream sales go up. But does this claim have strong internal validity? Probably not. Perhaps there is another variable, C, that is causing the increase in these two variables. Maybe the temperature outside. The hotter the temperature is, the more people buy ice cream, but also the more people go to the beach and are attacked by sharks. Here, there was actually a third variable that was causing the relationship between the first two variables. Also note that internal validity is not relevant to frequency claims, since these only describe one variable. When interrogating frequency claims, we will want to focus on construct validity and external validity. Statistical validity may be relevant here as well. Remember, construct validity is how well a conceptual variable is operationalized. For example, 80% of college students have been depressed during the last year. How is depression operationally defined? Were college students simply asked if they'd ever been depressed during the last year? Or was the frequency claim based on a score on a depression inventory, or records from psychological services on campus? External validity, also known as generalizability, is how well the results of a study represent the people or context besides those specifically involved in the study itself. For example, 72% of the world smiled yesterday. Which people did they survey, and how did they choose their participants? Did they include only people in major urban areas? Did they ask only college students from each country? Or did they attempt to randomly select people from each region of the world? Statistical validity, also known as statistical construct validity, may also be relevant here. Remember, it's the extent to which the study's conclusions are reasonable and accurate. The questions asked will vary depending on the claim. When interrogating frequency claims, percentages are usually accompanied by a margin of error, a statistic based on a sample size which indicates where the true value in the population probably lies. As a reminder, association claims involve the relationship between two measured variables, so we must interrogate construct, external, and statistical validities. Again, construct validity here is similar to construct validity for a frequency claim, except now you have two conceptual variables that need to be operationalized appropriately. For example, people who multitask are the worst at it. How are the frequency and ability to multitask measured? Ability to multitask could be measured by self-report, by simply asking how good are you at multitasking, or by an observational measure in which participants are given a task that requires them to multitask. Frequency of multitasking could again be self-report. Keep track of how many times you multitasked, or by observing participants directly. External validity again asks, does the association claim generalize to other populations, contexts, times, or places? For example, for the association between expressing gratitude and relationship length, you would ask whether the results from the study's participants, 194 California college students currently in a romantic relationship, would generalize to other people and settings. Would the same results be obtained if all of the participants were Midwestern couples 45 or older? You can evaluate generalizability to other contexts by asking, for example, whether the link between gratitude and relationship length also exists in friendships. Finally, statistical validity, when referring to an association claim, is the extent to which the statistical conclusions are accurate and reasonable. There are two aspects of statistical validity to consider: strength and statistical significance of two kinds of mistakes. Strength is how strong the association is. Some associations are strong, and others are weak. Remember that the stronger the association, the more accurate our predictions will be. Statistical significance is whether an association is, well, statistically significant. If so, then the result is probably not due to chance based on that sample. If an association isn't statistically significant, then the result probably is due to chance. When interrogating the statistical validity of an association claim, there are two kinds of mistakes that can be made: a type 1 error and a type 2 error. A type 1 error is essentially a false positive. A study might mistakenly conclude that there is an association between two variables in their sample when there actually is no association in the population. You want to increase the chances that you will find an association only when there really is an association. A type 2 error, on the other hand, is a miss. A study might mistakenly conclude from a sample that there is no association between two variables when there actually is an association at the population level. You want to minimize, or at least reduce, the chances of missing associations that are really there. While we want to avoid both of these error types as much as possible, depending on the context of your study, one type may be more consequential than the other. For example, when investigating the link between a new drug and cancer, there would be a high consequence for a type 2 error if you were to say that there was no link between the drug and cancer when there really is. However, in another context, a type 1 error may be more detrimental. For example, say a new form of birth control was developed and found to be 99% effective, but didn't actually reduce the chance of pregnancy. Here, a type 1 error was made, where an association that didn't actually exist was incorrectly found. In statistical research, we can adjust our alpha level or our bias towards finding either a type 1 or a type 2 error, depending on the consequences of each. You may have learned in your statistics class that psychological research often uses alpha levels of 0.05 or 0.01. By using smaller alpha levels, here 0.01, we are reducing our chance of finding a type 1 error or false positive, but increasing our chance of finding a type 2 error or a miss. Let's shift now to talking about how we can interrogate causal claims, or a claim that one variable has a direct cause on another variable. Remember that because causal claims state that one variable causes another variable, they use directional verbs like leads to, affects, or influences. There are three criteria for causation. 1. Covariance. This simply means that two variables are related. Association claims fulfill this criterion. 2. Temporal precedence, which simply means that one variable comes before the other variable in time. Because the research is manipulating one variable and then measuring the other variable, the researchers know that manipulated variables come before the outcome variable, which is measured after the manipulation. And 3. Internal validity, also known as the third variable criterion. A study should be able to eliminate alternative explanations. In other words, variable A is the only thing that changed when measuring the associated change in variable B. In order to support a causal claim, a researcher needs to conduct an experiment in which one variable is manipulated and the other is measured. In an experiment, an independent variable is the manipulated, or variable, cause in an experiment. In the example in the graph on the right, the type of lessons are the independent variable, and they have 4 levels: keyboard, voice, drama, and no lessons. The dependent variable is the measured variable, or effect, here IQ. Random assignment is important. Random assignment is a method of assigning participants to levels of the independent variable, such that each group is as similar as possible. Flipping a coin or rolling a die might be a way to fairly distribute participants to each level of a variable. This increases internal validity by controlling for potential alternative explanations. For example, we know that it was the lessons that caused the differences in IQ and not something else, because IQ was similar at the beginning in the 4 groups due to random assignment. Sometimes an article in the popular press may sound like it's a causal claim when really it's not. Let's look at these 2 examples and break down their types of validity. Do family meals really curb eating disorders? First, is there covariance? Yes, there is an association between family meals and eating disorders. Is there temporal precedence? Did the family meals increase before the eating disorders decreased? It's not really clear. Is there internal validity? No. We can't rule out third variable explanations without an experiment. Some other possible explanations are, perhaps children from single-parent families are less likely to eat with their families and are vulnerable to eating disorders, whereas children who live with both parents are not. Maybe high-achieving children are too busy to eat with their families and are also more susceptible to eating disorder behavior. These are questions that can only be ruled out by an experiment that manipulates the variables directly. Let's look at this other example. Does social media pressure cause teen anxiety? The relationship sounds causal, but is it? Again, let's look at the different types of validity tests. First, is there covariance? Yes, the results showed that teens who felt more pressure to respond immediately to social media were also more anxious. Is there temporal precedence? No, this was simply a correlational study in which both variables were measured at the same time. And finally, is there internal validity? Again, no. It was not an experiment, so it didn't rule out possible alternative explanations. We have been emphasizing internal validity because it is only important when interrogating causal claims. However, we still need to consider the three other types of validities. Construct validity is always important regardless of what type of claim you're making. You need to consider the construct validity of both the manipulated variable and the measured variable. Remember that external validity asks, do the results generalize to other people or contexts? This probably isn't paramount since internal validity tends to be emphasized in experiments, and internal and external validity are kind of like two sides of a coin. As internal validity increases, external validity decreases, and vice versa. Finally, statistical validity describes how strong the relationship between the independent variable and the dependent variable is. Is the difference between groups statistically significant? This is also important to keep in mind. It's impossible to find a study that satisfies all four validities at once. So how do we prioritize the different types of validity? Researchers must decide on their priorities according to the goals of each individual study. For example, internal validity is typically a top priority when making causal claims, but not necessarily when making frequency or association claims. This table is a good summary of how we interrogate the three claims: frequency, association, and causal, using the four big validities: construct, statistical, internal, and external. It provides a good summary of what we've been discussing. You can use this to help organize the relationships between each claim and validity. So let's wrap up this week's topics. We talked about different types of variables versus constants. We talked about measured and manipulated variables, and how conceptual variables are operationally defined in order to be measured. We talked about the three claims that can be made about variables: frequency claims that describe how often a variable occurs, association claims, which describe the relationship between two or more variables, and causal claims, which describe how one variable causes another. We also talked about the four big validities: construct, external, statistical, and internal validity, and how they can be used to interrogate and question different claims. Finally, we talked about how we should go about prioritizing the different validities based on the needs and design of each individual study.